Okay, so if we look at these examples now, we're going to go through those rules stepwise. And it helps to start off with the same kind of thought process you had in Chapter 2. When you're looking at something and you wanted to name it, you say to yourself, well, what's written first? What kind of compound is this? So this has a metal first, so that tells me right away it is what? Ionic compound, right? So it's made of lithium ions and oxide ions. This is a monoatomic lithium ion and a monoatomic oxide ion. So the charge on lithium is +1. So the oxidation number is +1. The charge on oxygen is -2. So the oxidation number is -2. And you'll see me write this like O2-. If I'm writing a charge, I write the number first and then the sign. If I'm writing an oxidation number, I write the sign and then the number. It doesn't matter, but I do that for me. It's my way of keeping track of which one I'm talking about. Is it real or not? Okay, so these are not real charges. So now here's the addition part. I have 2 lithiums with a +1 oxidation number each, so 2 times +1 is +2. I have 1 oxygen times a -2. +2 minus 2 is equal to 0, so everything's good there. Okay, sodium hydride. This is a sodium ion. It is a +1 charge, so it's a +1 oxidation number. This is a hydride ion. It is a negatively charged hydrogen anion, so it's -1. So +1 minus 1 is 0. Now this next one is not an ionic compound made of monoatomic ions. This is a compound made from a polyatomic ion. So when we look at this, those rules no longer apply. So as we keep going down the rules, we don't have any rules for phosphorus, and the first rule is hydrogen. So hydrogen's a +1. The next rule is oxygen's a -2. There's no rule for phosphorus. So 3 times a +1 is a +3. 4 times a -2 is a -8. And this has to add up to 0. So now we say, okay, what do I need to get 0? And I need 5, right? So I need a +5. So 5 divided by 1 phosphorus, the oxidation number on phosphorus is +5. Okay, let's look at this one. H2O2. Well, I know that hydrogen is a +1. That's the first atom-specific rule. I have 2 hydrogens. That gives me a +2. And this has to equal 0. So I need a -2 divided by 2 oxygens gives me a -1. Well, I thought oxygen was supposed to be -2, but this is hydrogen peroxide, H2O2. So it is okay, and going through the steps, applying the hydrogen rule first and then the oxygen rule led me to the -1. Question? Okay, let's go back there. You said it was an H. Are you doing the 4 times the 2, the negative? Yes, that's exactly what I did. Timesing all of them like that? Yes. So 3 times the +1 is +3. 4 times a -2 is a -8. It adds to 0. When I have a +3 and a -8, that's a -5. So I need a +5. Divided by 1 gives me a +5. Okay? All right, so now let's look at the last one. This is the first one where we don't have a neutral species. This is the dichromate ion, so whatever I have has to add up to -2. So I don't know any rules for chromium. I know a rule for oxygen. 7 times the -2 is -14. So what does this need to be equal to -2? 12. Divided by 2 gives me a +6 for chromium. Now, as a beginner, you look at that and you're thinking, well, wait a minute, chromium doesn't make a +6 ion. Well, no, it doesn't. It makes a 2 or a 3. But is this an ion? No, this is chromium hooked up with a bunch of oxygens in a polyatomic ion. So it appears that the chromium has lost even more electrons than it has. Anastasia? I pulled it out of this list of rules that oxygen is a -2. Okay? And we didn't have anything for these rules yet, right? In that one, there was no free elements, no monoatomic ions. I'm going to add them up. And so the first rule I had to work with was fluorine, and there was no fluorine. Hydrogen, there was no hydrogen, so oxygen was the only rule I had to start with. Okay? Now, let's have you get with your groups and do these on the whiteboards. Oxygen is -2 unless it's a peroxide, and you recognize a peroxide, then it's -1, or unless the oxygen is trumped by a higher hierarchy rule. Okay, why did you think it should be 0? Oh, the reason it's -2 is because of the charge right here on the species. Oh, right here. This thing has a charge. This is not a neutral compound. That's an ion. It has a charge. That's why. It's not about the oxygen that it's adding up to -2. It's about this -2. So if you had something like a phosphate ion, then they would all add up to -3. Or if you had the ammonium ion, they would add up to a +1. Okay, those are good questions. Okay, go ahead and get with your groups and do these on your boards.